We will start with foundation. When we say formwork, mainly talk about a concrete element which we have to create a form that's been designed. Now, in order to create that form, you have to provide a formwork, which can be plastic, wood, iron, a material that can withstand the pressure and durability. Now, in order to create a foundation, you have to provide formwork around the edges. You're not gonna cover the top, you're not gonna the bottom. For example, here the bottom is, you have plain concrete, and around it you'll provide this formwork. You have the reinforcement, then you pour the concrete. You might have different type of foundation. It's a single foundation. It doesn't matter. You still have formwork around the foundation. So when we say calculate the formwork for the foundation, we calculate this area. So for formwork, we calculate in area, meter square, things that are around this column. Or we might have ground beams. Now also for ground beam, remember those are on the ground. The bottom there is no formwork, only the side of it. The top you'll pour the concrete in it, so you only cover the area for the side. So for our project, we have it here. We're going to calculate formwork starting from foundation. We'll go for column and the rest of the members. Now, in order to calculate formwork, well, we start with foundation. Okay, say foundation. Now we have only one foundation here. We don't have a single footing. If not, you could have just write each of them. For example, single footing 1, 2, 3, and you can write their detail. Now what do we have here? Sorry. Well, we have one foundation here, one foundation. Now the dimension here, we have it, sorry, now the dimension that we have it, we'll take the length, because the formwork that we will be creating it, be providing for this foundation, will go around the perimeter. So basically you have to calculate the perimeter of this foundation. That means that you're calculating this perimeter multiplied by what? Multiplied by height. Remember, it's an area, will be something like this. Where do you get this thickness? The thickness of the foundation. So if I want to write it down, I can write it in two manner, because this is when I have it here, the same thing for the other side. So I have two of this one and two of the other one. Remember, this is, if you think over the 3D, will be something like this. This will be a box, something like this. So I have four sides. Two of them, we already know the dimension of this one before we calculated, and also we know the dimension of this side here. So one of them 9.6, the other one 17.5. So if I write it down, I can make sure, for example, I will write 1. What do I have? The length, for example, 17.5. I can even write 2 here. 217.5 by how much? By 0.4. What does this 0.4 means? The thickness of the foundation, because remember the formwork comes here. This will be the formwork that you're providing. It will come somewhere here, not the 10 here. This is just simply at the bottom. You provide a concrete for the base foundation. So this will be the formwork. 40 is the height of it, and the length basically we just measured from the plan. So I have 1 and the other side, so that's why I can multiply it by 2. Then this is one side. The other side I have a 2 times 9.6, which is this distance here. This is 9.6. 2 means the other side as well. The same thickness we have it, 0.4. So remember here, when we're calculating formwork, the unit will be meter square. Will be meter square. Now there is another way to calculate this. And instead of making 2, you can directly calculate the perimeter, all the perimeter, and multiply by 0.4. That's also possible. How do you calculate? Instead of this, for example, I can make it as 1. How can I calculate the perimeter? We know 2 times 17.5 plus 2 times 9.6. This is the perimeter of the foundation, and then we have 0.4. This is at one time you will do it. Perimeter means that you calculated the total distance around the foundation, all of it, which is 2 times 17, 2 times 9.6, and then multiply by 0.4. The summation of those two would be the same as this multiplication. So which one you prefer here doesn't matter. Or if I do this one, now those two summation, if I do their summation, should be equal to the one we have it down. So whether you do the 2 to separate them, or you can add them together as total length and then calculate the total at once. Whichever you prefer, it doesn't matter. But the idea is what? To know exactly where we have the formwork. Now this is for foundation. Very easy. What kind of foundation you have, it doesn't matter. You can just simply calculate the perimeter and multiply by the thickness of the foundation. That will be the formwork. Now sometimes you don't have formwork. Yeah, some places they do single footing and they will not have a space for the formwork. Now sometimes people create in this manner. The soil by itself will be the formwork. It's not recommended, but some places they do. You have to know according to the project that you're working with, do they provide formwork for the foundation or not? Here we're not talking about the practical, we're talking about how to calculate if it is available. Now in this project we don't have ground beam. But it doesn't matter. Even if you have a ground beam, when we talk about the formwork for beams, I'll remind you that ground beam will be similar to the beam that we're calculating here, except ground beam, they don't have formwork at the bottom. They only have it at the two sides. Now let's talk about columns. How to calculate formwork for column. Now before calculating formwork, you have to first know how the formwork will work, then you'll be able to calculate it easily. Now we're talking about column formwork. You have what? 4 sides of the column you have formwork. 4 sides of the column you have formwork. And how much is the height? Is equal to the height of the column. Now you remember height of column, when we calculated, we told you from somewhere to somewhere, to the bottom of the beams. Yes, and this is why we said that when we've been calculating the concrete for column, we said till the bottom of the beam. So this is what the column formwork looks like. Four sides of the column. So it means that I can calculate the perimeter of the column and then multiply it by the height of the column to get the area of this side. So basically we're calculating the area of the formwork around a column. Now let's say I'm choosing one of the column. So you can write here this is foundation, and you can come here columns. On the columns I'll write, for example, let's say I'll start with S2. S2 is 2560. We have a lot of 2560 years. Now I will write S2. Well, I'll come back to this number. I can change it later if I see there are similar to this S2. Now here I can write the perimeter directly, and instead of making it, for example, remember what we said, there is two sides of it. This is the 60, formwork will come here, formwork will come here, and then this side, and then this side. You can say 260, 225, or you can just put it once, the total perimeter, and you time the height of the column. So I'll write this total perimeter this time. 2 times 60, plus 2 times 25. Now this is the total perimeter. I need the height of the column. We already know the height of column S2. We said starting from where? According to the sections, we know it starts from the 50, level 50. It goes up to the bottom of the beam. Please, when you're checking these drawings, there are some misunderstanding or detailing that haven't been updated by the architecture when the civil engineer designed it. So whenever you want to calculate the height of the column, to be sure that do not check the architectural plans. What do you need? You only need the level of the ground where the column starts. You need the beam over the column, because the beams will be designed by civil engineer. So this level here, it might change. Well, I'm looking for S2. Yes. Now I need to know over S2. So remember, I'm looking for the height of the column here. So S2 will go for the beams. For example, it's first. Remember, this for the, I can make this one, this is for the first story. So I can write this as first. Now if the stories are the same, you can just multiply it by that much story as well. Now over S2 we said we have 3 beams. There are 60, 60. So we already know the inside of the home. We can use that idea which we explained in the columns. From here it's easy to be seen. Yes. We said that the total height of the that we needed, this is 260, 285 plus 15 became 3 meter, and we know the column, the beams will be measured like this 60. So we already know that 2.4 will come out as the length of the column. Now the 2.4, because total is 3 here, total is 300, and the beam, the 3 beams over H2, all of them are 60, so minus 60, we said it comes up to the bottom of the beam. It became 240, 2.4, 240 centimeter. Now if I know this one, I can, we already know it by the way from the columns, no need to calculate it here, 2.4. Why? Because you already, when you did the columns, you already calculated the height of the column, so you use the same thing. No need to recalculate it, but I just did it to remind you. So 2.4. Now how many, like S2 I have it? If I have similar columns, let's say I have similar columns here. What? I have S3, S4, S6, S8, all of them are 2560, S10, S9, S11, all of them are 2560. I can multiply them by that much, but we have to know if their height all are the same. So if their height all the same, I can just simply multiply by 8 because I have 8 of this one. Instead of S2, at that time I will write it what? I will write 25 by 60 column. Now I know that I have 8 column of this. No need to write, or I can write all the name S2, S3, S4, all of them. Look, I have 8 of them. Imagine if the second story, exactly the same thing, you multiply this one by 2, it will be 16 at that time. If they're continuous and they have the same length, the beams are the same, but sometimes it's gonna change. So you have to be careful when you multiply it by the similarity. And that's gonna give you, so just keep it for 1 here, because you have to check over all of these beams, sorry, over all of the columns to see if the beams depth 60 in order to have the same height. If that's the truth, then you multiply by that much amount of columns. Remember, this is the 1.7 is what? It's the perimeter of this column. Then you can do for the other columns as well. Thanks for watching.